Hello, my name is David Villar, and welcome to this presentation in which we are going to discuss some alternatives to one of the major indications for the use of antimicrobials in cattle, which is bovine respiratory disease. That probably accounts for the leading cause of sickness and death, at least in beef cattle in the US and probably many other countries. As we mentioned in a previous video, and we'll also see on this one, antimicrobial resistance is becoming a major public health threat. And there is considerable research showing the impact of overusing antimicrobials in animals, which is creating resistant bacteria, which can be a threat not only to our health, but to the same animals that we're sometimes trying to save. So we're going to see that the cornerstone of preventing bovine respiratory disease is what we call preconditioning programs, with the intent to have a successful transition from the farm of origin to the feedlot or a stocker operation. And that will hopefully replace the use of metaphylaxis, which is the term used to describe the treatment of an entire group of animals with an antimicrobial upon arrival to a feedlot. So on this first slide that I will come back later, I just want to highlight that bovine respiratory disease is a multifactorial disease in which the interaction of three key players, stress, viruses, and bacteria, need to be present for the disease to become apparent. They all tend to congregate at the same time. And the goal of a preconditioning program is basically to spread them out and mitigate them. This one slide is probably very simplistic. I apologize. I don't want really to offend or insult anyone's intelligence, but it'll probably get the message across. As long as the line of defenses of the animal is above the exposure to a given load of pathogens, that animal is obviously going to be healthy. But as you can see here, either of those lines can change at any point in time in life. If the defense lines drops below the exposure level to pathogens, or the exposure level rises above the defense lines, that's when the animal is going to become sick. And this is precisely what happens in bovine respiratory disease. I will not get into the details of why stress lowers the defense lines, but this is very well known that to happen when cortisol rises. Cortisol suppresses both the innate and the adaptive immune responses, and that increases the susceptibility of disease. And the acclimation period between the arrival of the calf to a feedlot and the time that he won't be susceptible to respiratory disease could be any time between 2 and 4 weeks. And that's important because that's the time when you may need to provide a metaphylactic treatment to protect him against disease. So as you can see on this other slide, preconditioning is meant to boost the line of defenses by doing a number of different things, which usually include keeping calves on the farm or ranch of origin for at least 45 days, so that you will wean them from the mother. You will vaccinate them twice with a vaccine for respiratory pathogens. One at 2 or 3 months, maybe when you brand and castrate them, and the second before you wean, ideally, or if you can not do so at the time of weaning, obviously. You will also train them to use feed bunks and water troughs. In some traditional programs, calves don't get to see a feed bunk until they arrive to a feedlot. And hopefully, if they were bull calves, they were castrated as early as possible, and also dehorned, because the later in life that you do so, it becomes a problem for the animal. I will show at the end of the presentation some vaccination programs that may fit your specific farm. So when we talk about metaphylaxis, the problem is that we need to suppress the excess load of pathogens, as you can see on this slide, that are exceeding the defense lines in order to protect those animals. And I will show you in a couple of studies that there are quite a large number of antimicrobials that are available on the market. And you may need to do so for at least 4 weeks upon arrival to a feedlot. So obviously there is no doubt that preconditioning is a good theme for the animal welfare, because it obviously improves the health and the well-being of the animal. The problem is that there are too many stakeholders along the beef production chain, and some stocker operations and feedlots may want to buy calves at lower cost that have not obviously undertaken any preconditioning or health programs, and which are obviously at much higher risk of developing disease. On this slide, we have some of the benefits of having calves undertaking those programs. I will not read all of them, but and you have some of the references at the bottom that you can check. But even if this is obviously worthwhile from a health perspective, unfortunately, it's not as widespread and common practice as you would like to see. And I think probably the reason is that many uh, customers or buyers have the perception that cattle at greater risk of bovine respiratory disease can probably be successfully managed with metaphylaxis, and that way they will have greater net returns than preconditioned cattle because they got them at a lower purchase cost from the auction market. Anyway, before I get into the specific studies, I want to show you the importance of separating some stressors so that they don't actually lower the immune defenses of the animal. Weaning is a combination of taking away the mother and the milk from the calf. If we do both and at the same time we load that calf onto a truck, it'll probably be a miracle if that calf doesn't break down with respiratory disease. So if we look at this way of weaning calves, they call it a two-step, and the first one involves preventing the calves from sucking the teat, while at the same time they can still drink and graze. And the second step is the actual separation from their dams. In the traditional way of weaning, when you separate the two, the calves will be howling and walking aimlessly for miles. But if you prevent them from nursing for a few days earlier, before you separate them, they will actually not vocalize and they will continue eating as normal. They have actually compared this method to the fence line weaning, which is in of itself a big improvement over separating cow-calf pairs out of view of each other. And they say that the benefits are even more dramatic for this two-step process, which they also call quiet weaning. So going back to this first slide that we said, there were many stressors uh, which are important players in the disease. And as you can see, they take place prior to entry or after arrival to a stocker or feedlot operation. And we're going to see a couple of studies with common industry practice in which either steers or bulls are bought from an auction market. They are castrated upon arrival, vaccinated, given antimicrobials metaphylactically, probably dewormed. So as you can imagine, the stress of transport, commingling with unfamiliar pen mates, overcrowding, being in a dry lot, maybe dusty, everything away from their home-raised farm with their mother. That's a lot to handle for those calves, and that makes them a very high risk of those viruses, which are already present in an otherwise healthy animal, to cause that initial damage in the respiratory tract. And basically, that paves the way to those bacterial agents, which are usually part of the normal flora, to start growing and creating havoc, so to speak. So the first study, the objectives were to compare the efficacy of enrofloxacin to tulathromycin for the control of bovine respiratory disease. And the second objective was to determine the prevalence of antimicrobial resistance in Mannheimia hemolytica in stocker calves that, as I just mentioned, are at very high risk of developing disease relative to other calves in the industry, because usually they're lighter weight, unweaned, commingle, basically everything that makes them more susceptible. So they enrolled a similar number of about 170 calves to each treatment group. They were acquired from a livestock auction market, subjective to the processing protocol that I just mentioned upon arrival. And basically, they were examined for signs consistent with respiratory disease, and they were given florfenicol if they had any of those signs. They also took nasal swabs on day 0 and then again 2 weeks later at the time of revaccination. And as you can see on figure 1, that Kaplan-Meier survival curve shows the time from arrival until the time of treatment for respiratory disease in all those 341 calves. And basically, 51 of 172, which is 33.7 of those in the enrofloxacin group required treatment, compared to 31 of 169, which is 18.3% in the tulathromycin group. So basically, the first finding of the study is that the odds of getting sick were much lower in the tulathromycin than in the enrofloxacin group. So with regards to the presence of Mannheimia hemolytica in those nasopharyngeal swabs, it was cultured from only a few individuals in the first day, only about 10% of those sampled. But then at the time of revaccination, 2 weeks later, it was present in about half of the individuals. And what is actually most interesting is that, and also it's been found in other studies, is that at the beginning, if those bacteria were susceptible to antimicrobials, at the time of revaccination, they have actually become either intermediate or resistant to most antimicrobials. This is actually summarized on this table, and as you can see, except for ceftiofur, the isolates collected from 35 stocker calves at the time of revaccination are now resistant to enrofloxacin, gamithromycin, tilmycin, tulathromycin, and it kind of varied for florfenicol. So the conclusion from this study actually is that the prevalence of pathogens increased from arrival to revaccination, and of most importance is probably that at the second sampling point, those bacteria are now multi-drug resistant. And obviously, the study showed that tulathromycin was superior to enrofloxacin because it protected more calves against bovine respiratory disease. This is actually a very long-acting macrolide, which results in sustained therapeutic concentrations at the site of infections for almost 2 weeks, compared to enrofloxacin, which may do so for a day or so. So what came to a surprise to the authors is that resistance was very similar in both groups and to the same category of antimicrobials, regardless of which treatment group that animal was in. I chose this other study to somehow highlight what are conventional approaches to current industry practices for stocker operations, and also the consequences for those calves from a health standpoint. Here they had a group of 50 high-risk stocker calves subjected to conventional practice on arrival, which included metaphylaxis with the macrolide tildipirocin to control bovine respiratory disease. This did not really seem to work because the proportion of animals that had to be treated for respiratory disease over the next 21 days was about 48%, which is more or less normal for this class of cattle. The one thing for which there are no evidence-based guidelines is whether to change antimicrobial class when an animal doesn't respond to the first shot, and also what is the length of time before a non-responsive case should be treated again. So as you can see here, what is a standard practice is that the first time an animal met the criteria, here it was given florfenicol, and in this case, 24 of 50 animals had to be given florfenicol. And if within 48 hours they were not responding, they were given a second shot of different antimicrobial. In this case, they chose ceftiofur, and it was given to 11 of those 24 animals. And if any of those 11 animals did not respond within 48 hours, they were given a third shot of a different drug, and in this case, they chose enrofloxacin. And as I say, there is really no consensus at the moment on this issue. From reading several other papers, it seems that those antimicrobials that were used initially in metaphylactic treatment should probably not be repeated, as the chances of having high levels of resistance bacteria are too high. The other objective of this study was to measure the prevalence of antimicrobial resistance during the 21 days period after arrival. So they took nasopharyngeal swabs on day 0, 7, 14, and 21, and they did culture and susceptibility testing. On day 0, 5 of 48 swabs were positive for Mannheimia hemolytica, and only one of those 5 isolates was multi-drug resistance. However, Mannheimia hemolytica was isolated a lot more in later days. 27 of 50 on day 7, 44 of 50 on day 14, and 40 of 50 on day 21. And all the isolated, except for one, were all resistant to just about everything: enrofloxacin, fluorphenicol, tetracycline, tilmycin, tulathromycin, everything except for ceftiofur. So one other interesting thing in this paper is that 27 or 50 samples isolated on day 7 were resistant to enrofloxacin, even before any of the cattle in that group had been treated with enrofloxacin. So it is possible that treating with other classes of antimicrobials is still giving a selective advantage to bacteria that are enrofloxacin resistant strains. And the final study that should get veterinarians thinking of their current practices is this one that looks at more than 1,000 bovine respiratory case submissions to the Iowa Veterinary Diagnostic Lab and compares their antimicrobial treatment history with the antimicrobial testing results for 3 of the major type of bacterial pathogens. The results are somewhat all similar for all the 3 bacterial species. So I'm just going to show the ones for Mannheimia hemolytica here, which are actually the more striking ones. And the percentage of isolates that were resistant to enrofloxacin, spectinomycin, tilmycin, and tulathromycin were less than 10% of the isolates from untreated animals, but it was more than 75% in animals with 3 or more treatments. So basically, this data show that overall antimicrobial resistance is very low in cattle that have not been treated. And this other slide shows the combined results with the other 2 bacterial isolates for Pastorella and Staphylococcus aureus. And again, the percentage of isolates from animals that did not receive antimicrobial treatment and were all susceptible to all 6 major classes of antimicrobials was 69.1%, with only 4.6% of the isolates from untreated animals classified as multi-drug resistance. In contrast, only 19.4% of the isolates from animals treated with 3 or more antimicrobials were pan-susceptible. 47.6 of those isolates were classified as multi-drug resistance. So to wrap up the presentation, this table is from a paper in veterinary clinics of North America. It has all the antimicrobials that are approved for metaphylactic use in the US. There are 8 injectables and 4 oral ones. And the problem is that neither one, unless you feed them continuously, will actually provide total protection for the entire period of acclimation, which, as I said before, could be up to 1 month. And the idea of this presentation was actually to present the alternative of preconditioning as a way to handle that transition from the origin to the feedlot. And as I said before, I also wanted to present different protocols of treatment. There are actually certified health programs that producers use also to increase the sale price of their beef calves. Vaccinating calves when they are very stressed probably counteracts if it doesn't abolish the effect of those vaccines. Here is a good protocol when the calves remain in the farm for 45 days post weaning. Weaning and vaccinating at the same time is definitely not a very good idea. You definitely want to separate those two practices. And if you're not able to do so, they suggest using an intranasal vaccine, which confers protection much faster than parenteral ones and also provides a level of immunity which is local. And that's probably what you want against respiratory pathogens. So as you can see, the vaccines here are mostly modified life vaccines, which have the main viruses, IVR, VVD, parainfluenza, bovine respiratory syncytial virus, and they usually include the two main bacteria, Mannheimia and Pasteurella. They're usually combined with Clostridium or the blackleg, also called the blackleg vaccines. So this was my last slide. Here is a list of the references that I used to prepare this presentation. I hope it was at least useful to present some of the advantages of preconditioning your calf and try to move away from using metaphylaxis. So until next time, bye bye for now.